Okay, so here we have a logarithmic equation that we're going to solve. Notice we have a natural log equals a natural log. So one way we've learned to do this is to subtract and get all the logs on the same side. We can do it that way, apply the quotient rule. But when you have a log equals a log like that, right away you can just go ahead and apply the one-to-one property for exponential. So what we're going to do is raise those two equal powers, e to those two equal powers. OK, now e and natural log, they're inverses. So you get the argument here. They sort of cancel. Equals 2 minus x. OK, so here we're left with a quadratic. So let's get that in standard form. Let's add the x squared to the other side. And let's subtract the 8. When you subtract the 8, you get minus 6. OK, so now this quadratic looks like it factors. First term first, x times x. And then 6 factors, 3 times 2. And I need it to add up to -1. So we'll make the 3 negative and the 2 positive. Positive 2 times -3 is -6. Looks good. Set each factor equal to 0. So x plus 2 equals 0, or x minus 3 equals 0. X equals -2, or x equals 3. Now we got to be careful. Remember, when we apply the one-to-one property for exponentials, we introduce the possibility for extraneous solutions. Now typically, the solutions that have been extraneous in the past are the negative ones. Usually you're tempted to throw away the negative answer. But in this particular case, we have to watch out. Let's look at 3. When I plug in 3 into the original, notice I'll have a natural log of 2 minus 3, which is a natural log of -1. Natural log of -1 is a domain error. The argument of the logarithm has to be positive. So the actual extraneous solution here is the 3. And when I plug in -2, 2 minus the -2 minus -2 becomes positive, and that's really a 4. Same thing here. When I plug in -2, you'll have an 8 minus 4, which is positive. So the argument is positive, and the argument is positive here when I substitute -2. So in this case, you got to be a little careful. The negative answer is not always the extraneous solution.